Hi, this is Mrs. Meyers, and today we will be learning lesson 1.5, exploring angle pairs. So our target is to learn all of these new words for angle pairs: adjacent angles, vertical angles, complementary, supplementary, linear pairs, and angle bisectors. And we will be writing equations and solving problems. This first part of your worksheet shows a review of what we've done before. We learned about a straight angle. And we know that a straight angle adds up to 180 degrees. So we were able to write an equation from this that makes sense to our diagram using the angle addition postulate. Okay, we also learned about other types of angles, like acute angles and obtuse angles and right angles. But today, not these individual types of angles. These are not what we're going to focus on. We're going to look at pairs of angles. So sometimes angles come in a meaningful pair, two at a time. And there are several types of angle pairs. The first one we have here are adjacent angles. You'll see we have vertical angles, complementary angles. All of these are the angle pairs that we will be looking at. Linear pairs are super important. Angle bisectors. So let's go back and look at adjacent angles for starters. Adjacent means things that are right next to each other. So two angles that have all of these properties, has to have all of these properties, are adjacent angles. In general, they look like this. Two angles that are right next to each other. So angle 3 and angle 4 are adjacent. Angle 1 and angle 2 are adjacent. They have to be in the same plane, coplanar. They have to share a side. So angle 1 and 2 share this side. Angle 3 and 4 share this side. They have to have the same vertex, and they have to have no common interior points. In other words, they don't overlap. The second term we're learning here about angle pairs are vertical angles. This is another pair of angles. They always come together. And these are two angles whose sides are opposite rays. So another way of thinking about it is when you have two lines that intersect, they form four angles here. And the ones that are across from each other, so angle 3 and angle 4, are vertical angles. And angle 2 and angle 1 are vertical angles. So I'm going to add here that they're always formed by two intersecting lines. So if you see two lines, then you know you can find some vertical angles. Okay, complementary angles. Complementary are two angles whose measures add up to 90 degrees. Each angle is called the complement of the other angle. So complementary angles do not have to be right next to each other. They do not even have to be on the same page. One could be in our classroom and one could be in a classroom in France, and they're still complementary angles if they add up to 90 degrees. So in this case, we do have a pair of adjacent angles that add up to 90. And we can tell they add up to 90 because of this box that's drawn. We know that's a right angle symbol. But they don't have to be adjacent. They don't have to be touching each other. Angle A here and angle B, if we take 43 and 47, we get 90 degrees. So they're also complementary angles. Supplementary angles, sounds a little bit like complementary. Supplementary angles are two angles whose measures add up to 180 degrees. So same idea. They don't have to be touching each other. They just have to add up to 180 degrees. So angle C and angle B, if we take their measures and we add them up, we get 180 degrees. So they are supplementary. Now they can be touching each other, but they don't have to be. I like to remember the difference between complementary and supplementary because C comes before S in the alphabet. C comes before S in the alphabet, and 90 comes before 180 when you're counting. So complementary is the 90 degrees, and supplementary is the 180 degrees. Okay. So let's practice these a little bit. In the diagram, name a pair of each type of angle. So now we are looking at this diagram, and we're trying to find a pair of supplementary angles first. So supplementary, we know, adds up to 180 degrees. So when we look at this diagram, we can look at the angle measures that they give us, and we might see that 62 plus 118 equals 180. So, therefore, these two angles, this one here and this one here, okay, are supplementary. They add up to 180. So, to name these angles, angle A, F, E, and angle D, F, E. Okay, complementary angles. We're looking for two angles that add up to 90 degrees. So again, we're going to look at our numbers that they give us, the angle measures, and we see that 62 and 28 add up to 90 degrees. So I'd like you to name those two angles, this one here and this one here. Try to name them and then come back and check your work. So the green angle is angle AFE again. And the red angle is angle BFC. You may have named it CFB. Either one is fine. Okay, adjacent angles. Remember, adjacent angles are two angles that are right next to each other. Now, there are other possible answers to these questions, but I'm just going to show you one of each. A pair of adjacent angles, two angles that have the same vertex and share a side. So maybe I'll choose BFC, and an angle right next to it might be CFD. So I'm going to choose these two adjacent angles. Angle BFC and angle CFD. Okay, vertical angles. Remember, we said vertical angles are always formed by two intersecting lines. I only see two intersecting lines in this diagram. This one, line AD, and this one, line EC. Notice this other thing coming off here is just a ray. It doesn't extend in the other direction, so that's not a line, it's just a ray. We can't involve that when we're looking for vertical angles. So the two vertical angles that I will name here are this one here and this one here. They're across from each other, vertical angles, angle A, F, E, and angle C, F, D. Can you name another pair of vertical angles? Pause the video and try to name another pair. Let's put another pair right here. Okay, so hopefully you did this on your own. You're coming back now and checking your work. The other pair of vertical angles would be this one and this one. So angle AFC and angle DFE. Those are the two pairs of vertical angles formed by the two blue intersecting lines. Okay, so use that same diagram for the following examples. State if the statement is true or false. Again, pause the video and try this on your own, and then come back when you're done. So, BFD and CFD are adjacent. True or false? BFD and CFD. False, because they overlap. Number 6, AFE and BFC are complementary. AFE and BFC are complementary, true. They add up to 180. AFB and EFD are vertical angles. This one is false, because AFB and EFD are not formed by two lines. So false. And AFE and AFD form a linear pair. Ooh, we didn't learn about linear pair yet, so we need to come down. We'll skip that one for now and come down. Linear pair is a pair of angles that are adjacent and together form a straight angle. So, in the diagram here, AFE and EFD form a linear pair. AFE. This angle right here, when we put it next to the other one, they form a linear pair. Together, they make a straight angle. So, a diagram for a linear pair is always going to be a line or a line segment with a ray coming off of it. You're always going to be forming two angles that sit on the line together, and so therefore they form a straight angle, and they are a linear pair. So the linear pair postulate says if two angles form a linear pair, then they have to be supplementary. If they form a straight angle, we know a straight angle is 180, and supplementary means 180. So a linear pair of angles will always add up to 180. Now, this is going to relate back to what we did with the section 1.4 with the angle addition postulate. But now we're using our new terms. Problem 3, they don't give us a diagram here. We have to draw our own. Angle KPL and JPL. So KPL and JPL form a linear pair. The measure of angle KPL, we're going to label our diagram. Remember, Lisa, always going to label first. KPL is 2x plus 24. And JPL is 4x plus 36. Now, we could have done this problem even without drawing a diagram, but since we're just first learning this, I wanted to give you the visual. What are the measures of KPL and JPL? Well, you're going to write your equation. 2x plus 24 plus 4x plus 36. And we know the linear pair is always supplementary by linear pair postulate. So they add up to 180. Okay? So we can set that equation up. I'm going to let you solve it on your own. Okay, so you tried that on your own, and here's the answer. You solve for x, you get 20. You plug 20 back in to the original expressions for these two angles, and we end up with 64 degrees for KPL and 116 for JPL. The last pair of angles we're going to learn about are angle bisectors. And an angle bisector divides an angle into two congruent angles. So we talked about the word bisector before. When something gets bisected, it gets cut in half, exactly in half. So we talked about segment bisectors, where a segment is cut into two congruent pieces. This is a segment bisector. So now we're talking about an angle bisector. We're going to cut an angle into two congruent pieces. This angle here and this angle here are congruent, which means that ray AY is called the angle bisector. And it's the angle bisector of angle, you name it, XAZ or ZAX. Okay, so this last problem here, ray AC bisects angle DAB. Here's angle DAB, and we have ray AC, we're told, bisects that angle. So therefore, we know this is cut into two congruent angles, and the measure of angle DAC is 58, and we need to know the measure of angle DAB. Read carefully now. They're asking us for the entire angle here, angle DAB. So they want to know what this whole thing is. I'm going to call that X because that's what we're looking for. Since we know that this is an angle bisector, if angle DAC is 58 degrees, then what must this angle CAB also be? Must be 58 degrees since it's being cut in half. So therefore we can say 58 degrees plus another 58 degrees by the angle addition postulate equals the entire angle, which is x degrees, and 58 is 116 degrees. Okay, so on the next page we are looking at a couple of things that we need to make sure we are aware of when we're looking at diagrams. Never assume things are congruent. Even if they look like they are the same length, you can't assume that. You can assume that two angles are adjacent. When you look at a diagram and it looks like they're connected and they're right next to each other, you can assume that they are. You can assume that angles are vertical angles. If it looks like two lines are intersecting, you can assume that they are forming vertical angles. And you can assume that the diagram is showing you a linear pair if it looks like the line is a straight line and there's a ray coming off of it. You can assume that's a linear pair. But you cannot assume things are congruent unless they are marked congruent. You cannot assume that things are right angles even if they look like they are right angles. So when you look at these diagrams here, you cannot assume that this is a right angle. You cannot assume that. You can assume that TWQ and QWV are a linear pair. That's okay, but you can't assume that they are right angles. Okay, so this quick recap I would like you to do on your own, and tomorrow in class we will go over those answers and see how you did. Just so that we are remembering, there are these angle pairs we learned: adjacent, vertical, complementary, supplementary, linear pairs, and angle bisectors. Those are the terms that you are required to know. Thank you.